Hey guys, just before we get into the lesson, I just wanted to let you know that you can catch these live on YouTube every Tuesday from 6 p.m. till 7 p.m. in the UK time. And that means you can be more interactive, you can ask your questions and they'll be answered. Okay, so without further ado, let's get into the lesson. Okay, hello and welcome guys to the 5th lesson in my kind of GCSE maths free tuition live lesson things. So over the last 2 weeks we've actually been doing a lot of trigonometry, and some of you may be glad to hear that this is actually the last lesson of trigonometry we're going to do. So today we're going to cover the cosine rule and the area of any triangle. Okay, so in the first week we did SOHCAHTOA, which is just for right angled triangles. Then we said, what about when we don't have right angled triangles, and we introduced the sine rule. Now we have the cosine rule, which is a little bit harder, and also we need to be able to work out the area of these triangles. So to start us off with, we're going to just focus on the cosine rule. Now, let's first draw out a generic looking triangle, okay? Oh god, okay. Perfect triangle. And if you remember, we can label the angles and sides A, B and C, and it doesn't matter so long as the correct letters are opposite each other. So for example, I can call this A, and that's totally fine. And I can call this B if I want to, totally fine. I can call this C. Now, when we label these sides, we have to make sure that the letters actually match up. Okay, so if I zoom in a little bit here, as you can see, the C, the capital C is opposite the lowercase c, and the capital B is opposite the lowercase b, and the capital A is opposite the lowercase a. So other than that, it doesn't actually matter. I can swap all of these letters around, and so long as the same letters are opposite each other, it's fine. Now the cosine rule is a bit trickier, and it basically says that a squared is equal to b squared plus c squared minus 2bc cos a. Yeah, pretty big. The good news is that you, for most exam boards, you do get this on your formula sheet. If you're unsure if your exam board does, then just look up your formula sheet whenever you can, and basically you don't need to remember this. That's pretty good. Okay, so if we have a look at what this is actually saying, it's saying that if I take one side, so A, and I square it, that's equal to both of the other sides added together and squared, so squared and added together, minus 2 times those sides times cos of the angle between them. Okay, so this would be useful if you want to work out, so if you have 2 sides plus angle between, and you want the third side, which is also going to be the side opposite the angle, right? Because it has to be. Okay, so now you should be able to realize that I can actually rewrite this formula for both of the other sides now, right? But keep in mind, the actual letters don't matter, right? So if I wanted to find out, let's say I wanted to find out this side here, instead of rewriting the whole formula, I can just call this A and change this angle to A and so on, right? There's nothing stopping me doing that. But something that you might want to consider is the fact that, you know, all it's saying is the side opposite the angle is equal to both of the other sides added and squared, minus 2 times both those sides times the angle between them. Okay, so the actual letters don't matter that much. Okay, but one thing you might realize is that you might actually want to work out an angle. So another way you want to use this formula is to work out an angle when you have 3 sides. Okay, now this does get a bit tricky. Okay, so if I rearrange this for cos A, which is the angle, then what I want to do first is move this thing over to the other side. So just flip the sign. So a squared plus 2bc cos A equals b squared plus c squared. So again, you don't need this middle bit. Minus a squared from both sides gives me 2bc cosine A equals b squared plus c squared minus a squared. And this is where it gets, the order is going to matter. Divide both sides by 2bc and you get cos A equals b squared plus c squared minus a squared over 2bc. And this is when you have 3 sides want an angle. Now, you have to be really careful, because if you look, b and c are interchangeable, because b squared plus c squared is the same as c squared plus b squared. It doesn't matter, right? And likewise, 2 times bc is the same as 2 times cb and vice versa. But the angle you're working out is the one opposite to this negative side. Whoops. Okay? So in this case, it'll be this angle because this side is negative. Okay? Just be very careful of that. Now we're going to do some practice right now. I'm going to show you it's really not that bad. The equation's long, but like I said earlier, in most exam boards, in virtually all of them, you get given this formula, and you can just check your formula sheet to see if it is on there, okay? So you don't really need to worry about remembering it. The thing I want you to actually learn is the fact that the angle that you have has to be opposite the side. And then just label that A, and you're done. Everything else falls into place. So, hopefully that makes sense. And what I'm going to do is actually do some questions with you now, okay? So let's go down and look for the first exam question. So we have an angle, and we get the sides that make up that angle. Good, we can use the cosine rule, okay? So again, with questions like this, you're always going to ask yourself, are you going to use the sine rule or the cosine rule? And honestly, it's up to you. You can normally use both. So in this case, I have two sides, the angle between them, so it implies cosine rule. And it says to work out the value of x. So what I'm going to do is say, well, this is my angle, so I'm going to label it capital A, which makes this side lowercase a. That makes me happy because the formula here has a equals. A squared equals technically, but a equals, right? Now, it doesn't matter what I label the other two. I can call this one B and this one C, or the other way around, because it doesn't matter. Okay, so what we're going to do here is we're going to say that A squared is equal to B squared, 13 squared, plus C squared, 10 squared, minus 2 times 13 times 10. Again, it really doesn't matter the order in which you do these. Cosine 100. Okay, so just as a reminder, the formula I'm using is A squared equals B squared plus C squared minus 2BC cos capital A. Okay, so all we need to do is use a calculator now. Just as a something that might hopefully soften the blow a bit, this only comes up on calculator. Okay, and the reason for that is it's a very complicated formula. They're not that mean. Okay, so we have 13 squared plus 10 squared. And again, just enter it exactly as I've entered it. Minus 2, which also means using brackets as well, just to be 100% sure you're going to get the right answer. And then cos, I was about to type cos there, that's a bit embarrassing. 100. And again, remember, if I make this bigger, the one thing you want to check is that this capital D is highlighted. It means you're in degrees. If not, shift menu, angle unit, degrees. Number 1. Easy peasy. So if I make this smaller again, because that's a bit ridiculous, we don't need it that big. Equals, I mean, 314.148, blah, 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 right? So I'm going to write a squared. And this is the really important bit. This is a mistake that I see a few students make. Is they leave this as their answer because they just write equals 314.14. If you look, that's what a squared equals. So a is actually equal to the square root of 314.14 ... Okay? So just keep that in mind. Now on your calculator, instead of having to write that whole number in, I'm going to show you a bit of a trick. So if I just press square root, there's a button next to the equal sign that says A and S. Okay? Now A and S is really, really important and useful to know. Right? What that stands for is answer. And what it does is it stores whatever you previously had after you pressed equals. So in this case, my A and S is now 314.14, I think it was 8, blah, blah, blah. So if I press equals, that is the same thing. Let's do it to one decimal place, so 17.7 centimeters. And again, remember your units. Centimeters, and that's to 1 dp. Okay. Now, just to prove it, prove the point, is this ANS is now equal to 17.724235556. So if I press equals again, it square roots that. And I press equals again, it square roots that. Square root, square root, square root, and then so on. Okay. So it's a useful thing to have for iteration as well, which tends to come up towards the end of paper 3 normally and paper 2. But anyway, that's another topic for another time. So let's get on to question 2 and see if we can have a look. Well, now it's labelled A, B, and C for us, right? But I don't care about their labelling, okay? I have an angle and the sides that make it up, right? So I'm going to label this locus A, I'm going to label this B and this C. I don't care about the way they've labelled it, however, I've actually matched it up. Subconsciously, I guess. And that works fine. We have an angle, the two sides that make up that angle, and we want the opposite angle, BC, right? So we're 100% cool. So once again, we have a squared equals b squared, so I'm going to make that 7 squared, plus c squared, 5 squared, minus 2, 7, 5, because it's 2bc, cos 42. Okay, and then I'm going to write a squared equals... So again, if you want, you can do this all in one. Actually, I'm going to show you how to do it all in one step, right? So if I were actually doing this question, or I wanted to work out what the answer was, I guess those are the same thing. I would do 7 squared plus 5 squared. Oh, why am I? Minus 2 bracket 7 close bracket open bracket 5 close bracket cos 42, right? I'd press equals. And I wouldn't write that down. I'll just do square root answer equals. Done. And it says to give it to 3 significant figures. So that's 4.69. So the reason why this is quite useful, and that's to 3SF, and that's in meters. Now the reason why this is quite useful is sometimes what I see pupils do. So if we go back, that's my answer, right? And what they will do is they'll say, okay, a squared equals 21.9. Then they'll square root that and write that answer, which can sometimes make this value slightly wrong. Right? So, to prove my point, let's say if I was a student, I'd probably write 21.9. So if I write the square root of 21.9, I actually don't know if this will be slightly different. Ah, there we are. So to 3 significant figures, I get 4.68 instead of 4.69. Okay? Normally doesn't matter, but again, it's just showing you that the answer is technically slightly different because you're rounding. Okay, so let's just keep going. We've got quite a lot to get through, so let's just hammer through as much as we can. Perfect, there we are. We have a different style of question. So what do I want to label A, B, and C in this case? Well, if I don't know the angle and I know all 3 sides, I want the side opposite the angle to be A, which makes the angle A. Okay. Now, you may have seen online kind of 3 cosine rule formulas where what they do is they change this to from a squared to b squared, and they change all the letters around, right? Which might be why you might be slightly scared. It's not necessary. I've never seen it really, the fact that you need it. But if you do, all they're doing is swapping the letters around. So if I make this b squared equals, all I do is I've replaced A with B, so replace A with B, and then C squared stays exactly the same. So it doesn't do anything, right? It doesn't make a difference, really. All I'm doing is replacing the letters. But I personally have never seen a question where that's required to do. Oh, sorry, my voice went. Anyways, so I want an angle instead of a side. So what you can do is you can either memorize this formula, which they don't give you always, or derive it. So rearrange the expression. It's not too bad to rearrange, okay? So I did the rearranging slightly earlier if you are interested. But if you want to remember the formula, no harm, no foul. So again, let's sub our values in. So we have 15 squared. And this, it does matter which one goes first, right? Because we want to make sure we're subtracting A. We have to subtract A. Otherwise, we're going to get something hideously wrong. Then 2, 15, and 16. Okay? Now, bear in mind, this gives me cos A. It doesn't give me A, which is the angle. Cos A is not the angle. Okay? So you can do one of two things. You can work out what this is, write equals some answer, and then do A is equal to cos inverse that answer. That's fine. You get the same answer, all good and hood. Or what you can do is be really fancy and do the whole thing in one line, like some kind of mad scientist. Okay? Like that. It will give you the same answer, okay? So if I do this in steps, again, if you're braver than I am, you're more than welcome to do it. So 15 squared plus 16 squared minus 20 squared over 2, 15, and 16, right? So again, equals, that gives me that, cool. And then remember, I can use the answer button, which is exactly what I wrote here. So inverse cos, remember, when we're trying to find an angle, we always have to inverse cos, and that's the yellow text above the cos button. So to get the yellow text, I press the yellow button. Yeah, fairly self-explanatory. And, oh god, this is way too huge. Right, there we are. And then just press answer, close bracket, done, deasy, 80.28, blah, blah, blah. 3 significant figures means it's 80.3 degrees. Again, remember your units. So you may notice that these questions are all roughly 3 marks, right? So 3, 3, 3 so far. And I've written a lot of working out, and that's good. You get method marks, nice and easy. But I can do the whole thing on my calculator in one line and get 3 marks. So although the cosine rule tends to be something very, very difficult, it's not that bad once you practice with it. And in my opinion, it's easy marks. Okay? Once you know the kind of setting of it. Okay? Perfect. Okay, so a few people have joined late and a few people have also left. So if you have missed anything, please just let me know in the chat. Oh, good question. Yeah, so where it turns up. So the way your paper is structured is that the last few questions will tend to be kind of unseen questions. Okay, so questions that they can kind of throw something weird at you. So this can come up. This kind of question here that I'm doing right now is going to be roughly the middle of the paper, of the higher paper. However, I have a question later on which is the very end of the higher paper, and it's one of those kind of unseen parts. So 10% of your marks needs to be unseen, so where they throw you in a situation that you haven't seen before. Okay, so to give you a little preview of that, it would be a question like this towards the end, but something that's right at the end is something like this. This is literally a 5-mark question. It would be literally the last question or two. Okay, but the ones I'm doing at the moment, roughly the middle. Okay. But yeah, we're going to get into some more interesting ones in a second. Okay. So, question 6. So they give us 3 sides, so that means we have to use the cosine rule because we don't have any angles for the sine rule. And they want us to work out the sides of angle ABC. So if you remember, the second letter is the one where the angle actually is. So we're looking at this angle here. And they want us to work out ABC, so that's this angle here. Now, they've labelled it B. I'm going to label it A because they don't make the rules, I do. So my side opposite is here. B and C really doesn't matter which way around you do it. We want the angle. So again, we can just use the formula we've either remembered or derived. If you want me to go through how we got to this formula from the cosine rule, then please just let me know. And that's over. Sorry, this is actually incorrect. I was writing the cosine rule formula for a second. So it should be b squared plus c squared minus a squared over 2bc. I apologise for that. And if we sub in the numbers now, we have 5 squared plus 9 squared minus 10 squared over with 2, 5, 9. That's it. And then our angle is going to just be what we type it in, okay? So, hopefully that's not too bad. Again, do let me know if you're finding this tricky. But this is kind of the layout that you're expecting. So Shift Cos to get the inverse thing. And I'm going to do it all in one step like an absolute madman. So plus 9 squared minus 10 squared. Stop for some water in a second. 2, 5, 9. Close bracket. So I'm just going to show you that it does work if you do the whole thing in one step. 86, and it's to the nearest degree. So that's just 86 degrees. Okay. And that's it. That's 3 marks. So it should take you, so the examiner expects you to take up to 3 minutes to do this question. Okay. So again, take your time, figure out where you want to put things. Because honestly, it is kind of up to you at the end of the day. Bear with me 1 second, I'm just going to get some water. Also, just to run something by you guys, I suspect some of you are making notes, or you're kind of rewatching the videos to kind of go through the answers. So I can actually make all of these PDFs available. So I can change these into PDFs and you can download them and print them or look at them or whatever. The thing is, I was looking at a way to kind of distribute them. So one option was Google Drive, but it's a bit messy. So I am in the process of making a Discord channel. So if you guys would like that, then just let me know. And I'll kind of make sure I get it done before next week. And what I'll do is I'll put all the PDFs for all of the lesson content on there so you can redo the questions or kind of do that, okay? Yeah. Easy, exactly. Not too bad, right? Again, there is a question later on that I definitely want to go through because it is tricky. It's a 5 marker. Okay, once again, calculate the value of x. So I'm going to make x my a because it means I don't have to worry about doing anything else. And that means the other 2 sides can be labelled whatever the hell I want. So once again, we have cos A. Again, just rinse and repeat. Okay, so b squared plus c squared. Again, make sure I don't make that mistake. Again, minus 24 squared. Over 2bc, so 2, 21, 13. Then a will just equal whatever the inverse cos of that is. So what I'm going to do, again, another tip is just to go through and just change the numbers like this. So back, that'd be 21. Of course, that would be 13. This one is 24. Down. 13. Whoops. And 21. That looks correct. Perfect. And it says to 1 decimal place, 86.4 degrees. 3 marks. Remembering all the circle theorems. Yeah, that's a bit tricky. One thing you can do is actually practice using them in questions. So if you find every single question that has a circle in it, in the mark scheme you'll see that there are circle theorems referenced. So those are the big ones. So practice is the best way to do it. For the ones that you don't really apply in questions, it's just a bit of memory work. So what I like to do is write out all of the circle theorems and then write them out again and again. Okay, if you do that 10 times, you'll remember them forever. But mainly if you just use them. So you use most of them in the actual maths practice that we're going to do. Okay. Perfect. Okay, how many more of these do I have? Okay, so after this we do have a somewhat interesting question. So again, I suspect some of you might be even be getting bored. BAC, well that is this angle right here. So I'm going to label that A because I want to. So the opposite side has to be lowercase a. And then B is going to be here, B and C. 100% on every test? Yeah, that's practice, right? The more you do maths, the less likely you are to make mistakes. So just practice as much as your maths teacher does or has. And again, work out the size of the angle. So A is equal to, again, I'm going to write it as the inverse cos way just for the people that are doing it that way. 2 sides that are adjacent to it, so 5.2 squared plus 7.3 squared minus 6.9 squared, all over 2, and then again times the adjacent sides. 7.3, all done, and all we have to do is type that whole thing in. So I think I can, sweet. So on the bottom we have 7.3, 5.2. On top we have so the half AB sine C formula is one they're actually about to come on to. That works out the area of triangles. Okay, so what this is used for specifically is working out the angles or sides in a triangle. Okay, I think that's equals, and to three significant figures, so 64.5 degrees. There we are, and that is to 3S. All done. Okay. We're making good time. We do have to go through one more formula, but we still have over half an hour left, so it should be okay. And I've got to close that bracket, that's embarrassing. Okay. So far, are there any questions at all? Okay. Perfect, sounds good. Perfect. Okay, glad to hear it. So, again, this one is slightly more interesting because we have a four-sided shape split into two triangles. Okay? And we have to work out what the angle X is. So, bit of a problem, right? Because the angle X is in this other triangle here. Okay, so here's what we should do. In this case, actually, let me just turn on the light. Just to make it that bit better. Might make it a bit easier to see. Anyways, I really don't think that's improved it much, but whatever. So what we have to do here is, this is a right angle triangle, which means we're going to be using SOHCAHTOA. I put the H in ka, whoops. SOHCAHTOA for this right-angled triangle on the right-hand side, okay? The problem is that to work out the angle using SOHCAHTOA, we need two sides. We only have one. But if you look at this triangle over here, we can use the cosine rule to find out what this side is over here. Okay, so if I label this angle A, this side A, we're going to work out what A is. Okay, so let's get started. We have A squared equals the two other sides squared and added, so 10 squared plus 13 squared, minus 2 times those same sides, so 10 and 13, cos of 40. Okay, and that is going to give us our value after we square root it, of course. Okay, so again, go through it again. 10 squared. Now, you might be wondering, how accurate do we need our value? And honestly, three significant figures is fine, but using the answer button, you can actually keep it exactly right. So I'll show you how to do it that way as well. Okay. The answer won't differ by much. And so 69.82, don't forget square root the answer, right? Because we want it to be A. So what we can do is make this 8.36, right? And that's going to give us a pretty good answer, okay? Because we only need to go to one decimal place anyway. But this is now saved as the answer button. So you can also use that, okay? But let's do a little bit of recap on 2 weeks ago, the lesson. We want this angle here. This is trigonometry. So specifically, we're doing the cosine rule, and we're about to come on to doing the areas of triangles. Okay? But the overall topic is trigonometry. Okay? We need to label up this triangle. So the side opposite the angle we want, so if I draw a little dotted line going here, that's our opposite side. Opposite the right angle is always the hypotenuse, and the other side is the adjacent side. Okay? So if we look at this, let me rewrite this out just to make it a bit more clearer. SOHCAHTOA. we have the opposite side and the adjacent side, and we want the angle. So we're looking for opposite and adjacent. That's using the TOA part. So we're going to be using tan theta equals opposite over adjacent. So in this case, it's 8.36 over 5. Okay. Now, because we want the angle, not tan of the angle, we're going to also do the inverse tan. Okay. So we can call it x if you want to. Tan inverse 8.36. Now on your calculators, you can just write 8.36 over 5, or you can just do shift tan answer button over 5. You'll get the same answer, okay, to one decimal place, 59.1 degrees. That's it. Yep, absolutely. So just the letters. This formula is cosine rule. It's a squared equals b squared plus c squared minus 2bc cos a. Again, you don't need to remember this formula. It's given in your formula sheets. But it's always faster and more efficient to just remember the formula. The best way to remember it is just to keep using it in the questions. So what I used to do is literally write this formula out every time I used it. Growth and decay. The maths topic, or if it's the maths topic and you're talking about kind of like interest and depreciation, that kind of thing, I can definitely do that. That's coming up soon. Yeah. So that's like the percentage increase over time and percentage decrease over time, right? So like interest and depreciation. That's actually probably going to be the next lesson. So yeah. Yeah, no worries, that's fine. Absolutely. So for that question, that was a 5-mark question. So this question came up towards the end of the paper, and we did it in 2 big steps. It is meant to be difficult, so if you found that difficult, that's totally fine. Especially if this is the first time you're seeing this, but it's the end of paper question, so it's meant to be hard. Are there any questions on that? Cool. Perfect. Let's keep going then. So this is probably the hardest cosine rule question I've seen. A hold of the abstract, as in the ones that are like the unseen parts. There's not that many of them, but if you go to the end of every single paper and take those last few questions, those are the abstract questions. But what I would also recommend you do is go to the old spec. Now, the old spec is basically every exam before 2015. The actual content is the same. It's just they changed around where the questions appear and things like that. But if you do those questions as well, that would be excellent practice. But the actual content's the same. The cosine rule was discovered in 2000 BC, so like it hasn't changed. Okay, it's all the same stuff. Anyways, let's get on to this question. This somewhat scary looking question. I'll give you a second just to process how interesting it is. I mean, I say interesting. Okay, work out the value of x. Now they've actually given me all of the sides. So I'm going to label it the same way I've labelled everything before. I'm going to say this is A. Okay? And the opposite side is going to be A. It doesn't matter which one B or C is. That's what I'm going to start with, because it's the same way I've started every other cosine rule question. Just as a little aside, with these abstract questions, just writing out formulas gets you a couple of marks. An attempt gets you marks. Okay? But you'll find that you can work out what to do. So what I'm going to do now is, I don't know what to do, right? That's confusing. So I'm just going to write out the cosine rule. Okay, and just as a reminder, the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Okay, I'm just going to write out, now I'm going to sub it in, right? This actually gives me 1 mark. The second mark can actually come from subbing in the values. So we have Square root 73. Oh my god. I'll rewrite this with better handwriting, I promise. B squared, so that's x plus 2 squared. Plus c squared, which is 2x minus 3 squared. Minus 2b, which is x plus 2. C, 2x minus 3. Cos 60. Now this gives me a mark already, and I've done no maths, right? All I've done is substitute into a formula, but I've got marks even if I don't know what I'm doing. Okay, so that's a very key thing that I want you guys to remember. Okay, now what is the square root of 73 squared? Well, if you're unsure, by the way, this question, it could have appeared in the non-calculator paper. It appeared in the calculator one, so don't worry. But if you won't actually need to use, I'll show you. You won't need to use the actual trig functions. So whenever we have a square root of a number and we square it, it just gives us the number. So as proof, this is just going to give me 73. I'm hoping that's somewhat familiar to you. So I have 73. Right? Now, we have this bit here, which is 2 times a bunch of algebra times cos 60. Now, hopefully you know that cos 60 is equal to a half. So if I do 2 times cos 60, what's 2 times a half? It's 1. So 2 cos 60 just equals 1. So in other words, I can just get rid of that. I'm going to give you a few seconds. I'm going to do this question very slowly, just to make sure you're following each step. I think that's okay, yeah? Perfect. So, I can expand these brackets in my head, but given that you guys aren't near your exams yet, you probably haven't had that much practice. But if we do x plus 2 squared, let's work all of this out. Okay? So x plus 2 squared, that's the same as writing x plus 2 x plus 2. Use FOIL, right? Do you all know what FOIL is? We have first, outside, inside, last. If you look at this first thing, it spells out the word FOIL, yeah? Good. So if we look at the first two terms, x times x gives me x squared. The outside terms is 2x plus 2x plus 4, right? Outside, inside, last. So we have x squared plus 4x plus 4. So what I'm going to do is work out all of these. Yeah, perfect. Well done, Evie. Nice. I'm going to work out all of these individual brackets and then just sub the whole thing in again. So 2x minus 3. Again, if you can do this in your head, you're more than welcome to. But just for those of you that might not be able to, 2 times 2 is 4. X times x is x squared. Minus 6x minus 6x plus 9. Again, please make sure you're checking my work, by the way. It's very easy to make a mistake when you're trying to explain the stuff. And lastly, we have that will give me 2x squared. Outside will give me minus 3x plus 4x. 6. That's 2x squared plus x minus. Whew. I think you can tell how much algebra is going to be in this question, right? So, if I write the whole expression out now, after I've expanded and simplified everything, I have 73 on the left-hand side equals x plus 2 squared, we said was x squared plus 4x plus 4. 2x minus 3 squared gives me 4x squared minus 12x plus 9. And that last bit on the end gives me, bear in mind there's a minus sign. So I have to change the sign of all of this to make it 2 minus 2x squared minus x plus 6. So just to go over that one more time, even though I cancelled the 2, there's a negative sign. So everything in this bracket that I worked out has to change sign. Okay? So let's simplify this a wee bit. And I'm wondering if you guys might be kind of coming onto an answer. So let's gather the x squareds first. We have x squared plus 4x squared is 5x squared. Minus 2x squared gives me 3x squared. I then have plus 4x minus 12x, which is minus 8x. Minus another x gives me minus 9x. So one thing I like to do, by the way, when I'm simplifying is actually cross through the ones that I've done. So then we did 4x minus 12x, which gave me minus 8x minus another x. Cool. Then we have 4 plus 9, which is 13, plus 6, which is 19. Oh boy. Okay, that looks right to me so far. But again, you know, I'm only human. Minus 73 from both sides. Because actually, before I do that, hopefully you're looking now that finding out the value of x just means we're solving this quadratic. That's it. So this unseen question is all maths we have done before, but it's all brought together, right? We've solved quadratics before, and we've done the cosine rule before. But what about solving a quadratic with the cosine rule? Same thing. So I promise you, in an exam, if you get these weird questions, sub stuff into formulas, expand brackets, and see what happens. And I promise you a solution will present itself. You get most of the marks. You actually get up to 3 marks for getting down to here. The other 2 marks are for solving. So I get most of the marks without even answering the question. Okay? But to solve this, we need to make the equation equal 0, right, on one side. So 0 equals 3x squared minus 9x. And then 19 minus 73 is 54. Minus 54, that is. So to make this a bit easier to solve, I'm going to divide the whole thing by 3 because there's 0 on the other side. So we have 0 equals x squared minus 3x. And I know that we can divide that by 3. It gives us 18. And then all we need to do is shove that into brackets, right? So what we have here is we want 2 numbers that times to negative 18 and add to minus 3. I can think of minus 6 and plus 3. So x minus 6, x plus 3 equals 0. So my values of x are x equals 6 or x equals minus 3. Up to here, I've now got 4 marks. Good. Well done. Nice one, Evie. Now the question is, look here. It says value, singular. So I actually marked a student that did this question before, and they got up to this point and they thought they got 5 marks because they found both solutions, right? Cool. But it says value singular. 6, good. Evie, why did you pick 6? So 6 is correct. Give you a second to think about why. Because it's not negative. Good. Think about what x is. X is the length of a side, right? Now, does it make sense for a length to be negative? Like if I asked you to get a ruler out and draw a line that's negative 6 centimeters long, could you do it? No. So what you want to do is say x equals 6, not negative. And that is probably the hardest cosine rule question. At least one of the hardest. 5 marks, all done. And bear in mind, this middle stuff, once you guys get to your exam, I guarantee you guys are going to be able to do this in your head. So you'll be able to go from, well, where I've drawn the arrow, right? So you could do it in basically 4 or 5 lines, get 5 marks. Pretty good. Okay. Perfect. Yeah, so the only other style of question that you can find is something like this. Calculate the perimeter of the triangle. Okay? So I'm going to go through the area in right after this. It's really not that tricky. Is calculate the perimeter of the triangle. All you need to do is work out this third side here. Okay? So they give us the area of the triangle. So let's now talk about what the area of a triangle is when it comes to a triangle that isn't a right angle one. So if we have a look at just a regular triangle, okay, the formula for the area of a triangle is simply a half AB sine C, which Evie mentioned earlier. Now A and B are two sides, and C has to be the angle between them. Okay? So again, the letters don't really matter, okay? So the formula just says you want half A times B times sine of the angle between them. That's it. Okay? This question, yeah, it's a 5-mark question. I want to come back to it. I want some practice with this slightly on a slightly easier question, okay? Because this question is a bit long. Okay, so if I go down, I actually have some questions here. So I'm going to rewrite area. I promise I'll do that question before we finish. Okay, half AB sine C. So using that logic, right, A and B are the sides that make up the sine. Make up the angle, sorry. So that's how I'd label it. So now my area, super easy, is just a half 13 12 sine of 120 degrees. That's it. Not too bad. And that will give you the area of any triangle. Okay, so let's do it. Let's do a half. If you want, you can write 0.5. Kind of up to you. Half 13 12 sine of 120 degrees. 39 root 3, but it says to 1 decimal place, not as a surd. So 67.5 centimeters squared. 2 marks. Because it's easy peasy lemon squeezy. Okay. Let's do another one as practice, then we'll go back up to do the hard question, and then we'll see how much time we have left. Once again, my formula is just a half AB sine C. A and B are just two sides. C has to be the angle between them. So once again, area just equals a half That's another way some people write it, is they write it with time signs. I don't like that very much, but just showing you that there are different ways of writing these things. So instead of 13 we have 5, instead of 12 we have 8, instead of 120 we have 41. 3 significant figures, 13.1 meters squared this time. So again, pay attention to the units. Is that okay for the area? Lila, Evie, is that all okay? I think it's not too bad. Yeah, most of the other questions stay the same. Yeah, so let's go back and do that hard question then. Okay, so again, this is one of the only other like really hard questions I found, but you don't need the cosine rule. Technically, you can use the cosine rule, but you can also use the sine rule. I'm going to do it with the cosine rule. So let's have a look at the information they've given us. Okay, they've told me, and one other thing, this is about exam technique. Okay, for any maths exam you do, they never give useless information. Every number we get given, every value, has to be used in the question, in the answer, okay? We have 2 sides. Sweet. We have the area. That's interesting. We need to calculate the perimeter. So I'm going to work backwards. What do I need for the perimeter? I need this side here. Okay, so how can I work out the side? Do I have enough information? Well, I have 2 sides and nothing else. I don't have enough information. Okay, so how can I get more information? Well, I'm going to use the only other piece of information they've given me. There you go. Okay. So the area is a half AB sine C. So before we go on, does that logic make sense? Do you see my thought process? And this is how you should think in the exam, okay? You have to use all the information. Think about what you need. Think about how you can get it. So in this case, we get given that 100 equals... Now, what angle am I going to work out? Good question. AB are just the two sides that make up the triangle. Yeah, their lengths, okay? So, I was about to say, C has to be the angle between them, right? So in this case, my C is over here. So my A and B are these two sides. Because they're the only two lengths I've got given. So I have to call the angle between them C. I have to. Brilliant question. Well, first of all, if they gave you three sides, you can just work out the perimeter by adding. But I'm assuming you mean like if they give you if you want something else, right? Whichever one you want. Okay? The brilliant thing about trigonometry is it doesn't matter which one you choose. Okay? So for example, if I then had, let's say, these two sides over here and this angle, I would get the same result. Right? I will always get the right answer. So if they give you three sides, you can choose whichever one you want to discard. Because no matter which pair you choose, you get the right thing. Okay? In this case, you know, you have two sides. You need to use the angle between the two sides. That's all you need to know. Okay? Really good question though. So in this case, we have half. A is 19.7. B is 15.4. And we want sine C. So now I need to actually rearrange to get what I want. So times both sides by 2 to get rid of the half. I get 200 equals 19.7, 15.4 sine C. So if I rearrange this, I get sine C. If I divide both sides by these brackets here, I get 200 over 19.7, 15.4. Okay, and then C is going to equal whatever I say it does. All okay with that? This is a pretty long question, by the way. Like, unironically, very long. So I need to do the sine inverse. Because again, if I want the actual angle, I need to inverse sine to get rid of that. 200 over 19.7.4. 41.2. I'm going to leave it to three significant figures. Okay. And what I'm going to do is I'm going to get rid of this C now and write 41.2. I'm also going to get rid of this A and B. You'll see why. Now I need to work out the perimeter. Okay, so I have two sides and an angle. And I need the side opposite them. So this is just a regular cosine rule question now. I'm going to label the opposite side A and the angle A. And then B and C, the other two things. That may have confused some of you, right? But keep in mind, I control what sides are what. Okay? So I can change it from C to A. Doesn't matter. I'll give you a second just to digest what I just did. And if you have any questions, please let me know now. And then we can go forwards. Okay, it's okay if it doesn't make sense, just let me know. Is it okay that I can just reassign the letters? Because I'm using a different formula. Okay? Okay. Why? That's a very good question. The reason why I changed it is I'm about to use the cosine rule. Oh, never mind. which looks like this. A squared equals B squared plus C squared minus 2BC cos A, right? So if that's true, right? In fact, I'm going to... Okay. I think for next time, I'm going to turn down the latency. So there's a bit of lag, by the way, between what you're saying and what and when I see it, and then when you hear the response. So I'm going to change that to make it as short as possible. But yeah. So if I want to find a side, I want to label it A. That's the reason. Okay. But it doesn't actually matter. So now if I sub the values in, 15.4 squared plus 19.7 squared and it doesn't really matter which way around we do this. (41.2). So now what we'll do is just square root it as well. This is a long question, but we're right at the end, okay? Once we get this answer, I'm going to show you where you get some of the marks, just so you guys are aware, because I think that's always very useful. Squared, B squared. And again, please make sure you're checking to see if I'm making any mistakes. It's possible. Cool. And that'll be cos. Equals square root answer 12.89. That's kind of annoying. What should we call it? Let's call it 13. Okay, so this opposite side is 13. So far, we have earned 4 marks. And let me give you a breakdown on where that came from. 1 mark for substituting into the area formula. Yeah. And another mark for working out the angle. Another mark for substituting. Another mark for working out the opposite side. The last mark is working out what it tells you to work out, the perimeter. Okay? So the perimeter... If you remember how to work out the perimeter, you just add up all of the sides. So 19.7 plus 13 plus 15.4. And because it's a calculator paper and I'm incredibly lazy, let's just add this up by hand. 19.7 plus 13 plus 15.4. Whoops, that was close. And it's just a 3 significant figures, so 48.1 meters. Okay. So what do you think of that?